Today, we are representing a research proposal titled
Non-invasive frozen food quality assessment using microwave-based electronic systems.
This study investigates the potential of microwave-based electronic system to provide a non-invasive quality for evaluating the quality of frozen foods, aiming to provide insights to offer a more efficient, reliable, and scalable approach to maintain the quality of frozen meat products. This could lead to improved consumer satisfaction, reduce food waste, and enhance quality control in the frozen food industry. Thank you for your time and consideration. Jhonny Gultiano will now be discussing the background of the study.
So once again, I'm Jhonny Gultiano. Then to set the context, I want to briefly discuss the importance of our research topic. Our research focuses on non-invasive frozen food quality assessment using microwave-based electronic system. Microwave ovens as certified by the FDA are safe and efficient for cooking food, and their underlying technology has potential beyond heating. And this study explores how microwave-based system can provide a non-invasive, real-time solution for assessing frozen food quality. Then the objectives of our study will be discussed by Jhun Cacayuran.
Once again, I'm Jhun Cacayuran, and I will be mentioning our main objectives. The main objective of our study first is to understand the problem and define evolution parameters such as temperature distribution, moisture content, nutritional retention. Second is to explore existing technologies and systems such as magnetron technology, turntable mechanism, manual controls, basics, powers, and level. And third is to identify challenge and evaluation frozen food using microwaves, calibration, and data collection. This objective guided the research design and ensured the focus remain aligned with the problem statements. Our research problem will be discussed by Vincent Echin.
Hi, my name is Vincent Echin. Our research problem focuses on improving conventional microwave-based electronic systems to maintain quality and nutrients in frozen foods. Current systems focus on heating or defrosting, leading to uneven results and compromise in texture, taste, and nutrients. The proposed system uses PIC, microcontrollers, and NIR spectroscopy to measure frozen food quality during heating, eliminating problems like non-uniform heating, moisture loss, and nutritional degradation through real-time analysis and accurate control of microwave power. Despite previous studies, there is limited knowledge about this innovative solution. Mr. Fontanilla will discuss the scope and limitation.
Greetings, I'm Wilfrancis Fontanilla, and I'll be discussing the scope and limitation of our research. For the scope, it's focused on assessing food products that are commonly frozen. Most of these frozen foods tend to be in huge batches and are usually delivered in prolonged transit. These are only some of the factors that can affect the food's quality. So to assess said quality, microwave-based technologies will be used, accounting for different factors such as the type of food, temperature, and number of batches or quantities. The research would be limited to frozen meat products, specifically beef, pork, and chicken meat. These meats are commonly bought in huge batches, frozen in different temperatures, and upholding their nutritional value when frozen also comes to mind. These are the factors for choosing these meat products as our test beds.
So once again, I'm Jhonny Gultiano. So I will be discuss the significance of the study. This study is significant for improving quality control in the frozen food industry. This study addressed this necessarily, examining frozen food manufacturers by ensuring products consistency and reducing loss of frozen food quality. Then the second one is the smart appliance manufacturer by enabling integration of real-time food quality detection in appliances. Then the third one is fast food restaurants by optimizing inventory management and reducing the food waste. And the last one is for future researchers by serving as a foundational reference for advancing non-invasive food quality technologies. This innovation supports consumer satisfaction, reduces waste, and enhance operational efficiency across the frozen food supply chain. Then, it is the last part of the chapter 1. Then, the chapter 2 will be discussed by Wilfrancis Fontanilla.
Moving forward, I'll be discussing a review of related literature. The literature review explored key themes in food quality assessment with different techniques and methodologies, as well as using other technologies and incorporating them in various processes. While several studies covered the differences of conventional and microwave ovens, microwave-based systems, and its other uses and application in different foods, there was a lack of focus on applications in frozen meat products. Our research builds on this foundation, offering new insights into using microwave-based technologies in assessing frozen meat products. So, to discuss our Chapter 3, I'd like to introduce Frederick Sabado, followed by Jaymark Caparida.
My name is Frederick P. Sabado. Now I will discuss the Chapter 3 of our research, the research methodology and design. In this chapter provides the research technique as well as the technical details of the hardware and software the researcher used. In the design, we have 4 factors: the requirement analysis, with design, building prototype, and evaluation of prototype. So now, I will tackle first the requirements analysis. The researcher accumulated all of the necessary information throughout this study period to determine who will use these appliances, where it will be installed, and what needs will be necessary for its development. At this stage, the hardware and software requirements are carefully evaluated according to their uses and functionality. The researcher developed a non-invasive frozen food quality assessment using microwave-based to help the frozen food manufacturer grow their product with quality. In this phase of the study, the researcher gathered essential information to clearly define the needs and expectations for the development of the system. This involved identifying who will use these appliances, where it will be installed, and what needs are necessary. To achieve this goal, hardware and software requirements were carefully evaluated to ensure their stability. The next one is quick design. Once the requirements have been acquired, all of the concepts for what will be done in the system are created. Since rapid design just addresses the most important components in the ideas, it can greatly facilitate the creation of the prototype. Quick design is a streamlined process focusing on essential system components to speed up the prototype development. After gathering hardware and software requirements, the key concepts are identified and quickly designed. This results in the functioning prototype that demonstrates core features. Ms. Anya Jazmin will mention the next 2 factors of research methodology.
Our build prototype maintains the temperature range to provide a non-invasive solution for evaluating the quality of frozen food system that monitors the temperature inside the microwave base while the evaluation prototype is ready for a comprehensive evaluation based on the goals of our research, absent in order to identify its advantages and shortcomings. So, Mr. Jaymark Caparida will present our flowchart.
Greetings. Good day again. I am Caparida. I am discussing about flowchart, PCB layout, and schematic diagram. First, let's define what is flowchart is. The flowchart is the process on how the system works. It indicates step by step on how the system works on how to flow the microwave sensor. First in the flowchart are microwave transmitter. Under in the microwave transmitter, there is a microwave receiver and power supply. Secondly, under a microwave receiver, there is also signal conditioning, ADC, and a microcontroller. Lastly is a display module, temperature sensor, buzzer or indicator light, and Wi-Fi or Bluetooth module. In the schematic diagram, there is also a microcontroller unit or MCU display module, operational amplifier, signal conditioning, digital to analog conversion, DAC or buzzer, memory or storage, power supply and voltage regulation, sensor input, miscellaneous components. There is capacitor, resistor, and other supporting components ensure stable operation, filtering, and biasing of circuit. This schematic appears to be a data acquisition or monitoring system. It processes analog signals from sensor amplifiers, condition them, and convert them into a digital data for processing by microcontroller. The process data is then displayed on an LCD, saved in EPROM, or used to trigger a buzzer. In the hardware components equipment, there is a magnetron power supply, temperature sensor, display module, LCD or OLED, and lastly, this is a microcontroller PIC.
And that concludes our research presentation. Chapter closed. I hope this finding will help all of us move forward. Thank you so much for listening and attention to our presentation entitled
Non-invasive frozen food quality assessment using microwave-based electronic systems.